Welcome, everyone, to a conversation in cybersecurity. Joining me today is Cassie Crossley, VP of Supply Chain Security at Schneider Electric. And her recently published book, Software Supply Chain Security, is the focus of this conversation. It provides a comprehensive and in-depth view on supply chain risk and mitigation measures, and has been very well received in the industry. And joining as the host today is Bob Lyle, and he's the deputy chair of the Device Security Group at the GSMA Consortium. The GSMA is best known for the GSM standard in mobile phones and its mission in unifying the mobile ecosystem globally. Bob, is it Ricocity? Is that correct, Bob?
Riscosity.
Riscosity, there you go. A company that's focused on associated data flows in the supply chain. So without further ado, I'm going to hand it off to Bob and Cassie, and enjoy, everyone.
Thank you. And thank you, Cassie, for spending some time with us here. It's pretty exciting times for you with the launch of the book. And I think you've had a lot of great reception and have done quite a few interviews now. So this is becoming old hat for you.
Thanks for having me, Bob. And of course, also for being here with MergeBase.
Excellent. And I guess before we jump into some questions about the book, I was wondering if you could talk a bit about the motivation, what prompted you to, outside your day job, spend a significant amount of time over the last couple of years, I imagine, putting together a book like this?
Yeah, well, it was related to my day job in a sense that I work with suppliers all over the world, and providing them a background in product security and software supply chain security was new for everyone. They don't have a mature product security organization like we have at Schneider Electric. And so I was sending links, I would spend hours working with these suppliers, but also even the companies that we acquire. And I saw that there wasn't an entire view. There were people that were producing information for developers, but this is much larger than a developer issue. It goes into, and you just talked about device management on that intro. And device management is so much more than just about a software app or a SaaS or mobile apps. It's about the hardware and the firmware associated with it. So I really wanted to present that overall view so people could understand what is involved in the entire supply chain.
Excellent. No, that's great. And we're glad you made the contribution to the industry because lots of people are liking it. And I got I don't know if it comes through on video, but I have my copy here and it's well earmarked with little markers on different chapters. So I thought I'd jump into a few questions about a few of the key chapters that we saw. But one was on chapter 3, was on infrastructure. And recently, a couple of weeks ago, I was at the Mobile World Congress, so a big conference in the mobile ecosystem. And everyone kind of takes for granted that actually a lot of international calls, most of those are rerouted on undersea cable. And it was a big topic of conversation at the conference that some of the cables in the Red Sea had been reportedly severed or damaged. And that kind of was a sobering thought that it brought to mind of how we take for granted that the physical infrastructure is just there, and probably that's okay. You're with a large, multinational corporation. How do you help safeguard the physical infrastructure? What are some of the things you do with respect to that?
Oh, sure. And absolutely, people don't always think about the distribution methods and how things go across. So the infrastructure is from either, let's just even talk about a developer environment for a moment. There's that infrastructure, which could be a virtual private cloud, a virtual machine. It could be then moving and expanding onto labs. So all of us are using phones. Like there's labs and IoT labs and OT labs all around the world. So you have that infrastructure. Then you have the underpinning of that infrastructure just in a large corporation. Like, are you really monitoring and what's going on? So how are you assessing? I would say it as an industry, very good at monitoring normal enterprise infrastructure, right? But when something's out of the norm, labs or other environments, then you may not have the tools or even awareness of what to monitor. So as you were talking about for the infrastructure for cable, with Schneider Electric, we work a lot on low voltage and medium voltage. So that infrastructure out in the industry and how things are moved along, all of this digital infrastructure that's out there has, you've got to worry about resiliency, but you also have to worry about the supply chain of that. Who's the supplier managing it? Do they have managed services providing that? So all of that is part of that infrastructure. It's not, as I mentioned, not just in the developer. That information, the data, the actual software, the firmware, the packets, anything going across is all at risk for integrity and confidentiality and even availability in the case of the physical cables.
Right, right. So it adds another whole layer of complexity if software security wasn't enough.
Right.
So jumping around in the book, if we look at chapter 4 was a significant chapter, and I was looking at the figure 4.1 is the first figure there. It talks about application security tools and techniques spanning across the development lifecycle. Would it be advantageous, or is there a tool that can cover all 4 of these sections or all 4 of things? I'm sure that you use a lot of different security tools. But would it be advantageous if one tool is able to cover multiple parts of the effort?
Yes, absolutely. And we're seeing that consolidation or merging of tools and really being able to certain tools rather than being a niche tool where it only does this or only does that. I think the ones that'll really grow and expand are those that either come together or they expand those services so that they really see the entire view of all, for example, from a testing perspective and evaluation. Because really, when you're looking at that testing service and scanning, you want it to be, can you get to the point where it's automated and correctional? Does it know the corrections? And that's where AI is going to and is starting to play a significant difference too, is that it's even if you don't have it automatically make the changes, is to make the adjustments. So having those kind of tool bases where they are expanding the entire testing framework so that it's throughout the life cycle. And we see that more on the DevSecOps side, a lot of, let's just, something in the container management where they're looking at that entire base. It's still a bit more difficult in some of the old legacy pipelines and build pipelines, and the fact that it's not truly a pipeline.
Right.
We're still seeing that where it's harder to bring that together because a lot of these tools are also dependent on the languages that they're servicing or the environments. So it's never going to be 100% of 100%, but we are seeing a better breadth across a suite of products.
Okay. And I guess you were alluding to the fact that I guess if one tool could only do one part of the life cycle or development or process, it may be advantageous for that tool to maybe partner with others to try to
Absolutely.
have a holistic solution. So, okay.
Right.
Excellent.
And eventually maybe others may pick that up, but we're actually seeing, in our environments, especially with the push to having memory safe languages, sometimes they're not supporting C and C++. And a lot of our infrastructure and, technologies are still written in some of those older, code,
Right.
code languages and things like that, but they're not being part of the tool suites anymore, or maybe a Windows platform or things like that.
Right. Okay. Excellent. So jumping around again, if we look at chapter 7 was on intellectual property, and how does intellectual property IP and data protection factor into software management and supply chain security?
Yeah. I probably can't go a day without reading about a new intellectual property loss. I think there was a company that just put out a report saying how many keys and everything. It was almost over 12 million intellectual property objects were lost last year just on GitHub and GitLab alone. Just that it's doubling nearly every year. So intellectual property, once that is out there, even for a very short time by accident, then there are, let's just say, malicious actors and other people that are not malicious that are scanning those repositories and making copies of them all the time. So the moment it's accidentally released, this intellectual property, you've lost. Microsoft has lost entire AI training databases, terabytes of data, because they were accidentally published publicly. And we saw this several years back before Amazon put in the controls where by default S3 buckets were not set to public, and now they're set to private when they're first instantiated. So for many years, there were lots of data being accidentally released because of the S3 buckets. But we're still seeing, and even though GitHub and other package management places have been doing a better job of securing and trying to provide that more private nature, we're still seeing all the time these reports of accidental leakages into that space. And that is quite honestly a bit of awareness training. Developers, they don't do it intentionally. I mean, they're very embarrassed, and then sometimes there's repercussions from a job standpoint if they've accidentally released this confidential information out there. And I think that that's something that we've, in the finance space, in the HR space, we understand PII, but development organizations and engineering organizations really classifying that data and understanding what they're putting in there and how it's being released, it's still not structured enough and aware enough that they're, that this isn't happening. And unfortunately, even with, even if it's encrypted with quantum cryptography and, all of that looming in that standpoint, people are just going to hold on to that data until the day that, that it is breakable, and then they'll retrieve that. So it's a significant problem that we need to be doing more to pay attention to.
And I guess it sounds like from some of your response that I guess classification, proper training and classification of data, whether it's IP or not, is something important for an enterprise.
Yes, absolutely.
Related to IP, as an anecdotal comment, I've worked with some of the ISACs, the information sharing groups, and I think US universities are some of the most attacked, by bad actors, most attacked sites in the world globally, just attacked to gain access to the IP they have and the research they're working on and things. But if we jump around a bit in the book, I have some background in the past, as you know, in the software bill of materials space, and you have a large chapter on software transparency. There are a lot of naysayers out there, though, in the software bill of materials community or discussions that feel that SBOMs are a bad idea because you give away some of your secrets and you're opening those up to bad actors. What would you say to those naysayers, or do you have any guidance there around that?
Well, we also classify our SBOMs as restricted, and it requires a non-disclosure agreement for our customers to get access to it. And the main reason is it doesn't need to be out there in public form. Most of what we produce are for critical infrastructure. So it's really a need to know, right? It's different than some prosumer products. But those, a customer is purchasing that, they're depending on that, they're running operations on that, they're making decisions of procurement, and knowing what's in there is, I know that people don't like the food label analogy, but I think it's a good point, is to understand what before you procure it, or if you're going to operate in it, do you at least need and have that information to be able to say, I should be a bit aware of what I have in this tech stack. And it's not going to give you the answer unless the provider, this software editor, publisher, manufacturer, whichever word you want to use, provides you what's called the vulnerability exploitability information for that. But let's say you did assess and see that Log4j was in a component, at least you can watch it, right? You know that this product may be at risk. Now, if you don't see it in there, I've got a different diagram in there that says you still should be watching it, because if you don't know and they haven't identified that, as a potential item. So I think it's really important for those who are running it, whether you're operating a car, you may not be a technical person, but if you knew that it had a certain airbag in there, you want to know, should I be more cautious, or is there something that I might want to do? This is, again, that transparency. So I think that what we're seeing, the roadmap to the attacker, the other pieces, they can get that information. Unless it's an encrypted firmware, you can reverse engineer. I mean, there's tools to do that. You're not really hiding anything that they probably couldn't get their hands on. And so what we're doing is providing that transparency so that we hope people can make educated decisions or at least have enough insight so that they know to be aware and watch out for the security advisory or something on there.
Right. Okay. Very good points. And I think overall that SBOM ecosystem is still kind of in its early stages and is maturing. How would you describe, in your view, the kind of the state today and maybe how things look in your mind over the next couple of years as far as the use of SBOMs in the future?
Yeah, I still see that only a few of us have a program associated with really delivering these. I mean, some teams are using them internally at their companies and have been for a number of years. So I believe we're still at the beginning stage of the sharing. I think generation of generating those SBOMs are, I would say that any team could perform that activity with just a bit of reading, but the sharing and exchanging and how do you bring this together is much more difficult. And so I've been tackling this problem for quite a bit of time with different folks in the industry, as you know. And part of this is that so just think of a single component that we have for one of our data center UPSs. It has 34 first tier suppliers in the hardware and software, but there's in 500 entities, which could be open source and different suppliers and logistics and everybody else associated with that one product. And so all of those upstream suppliers, whether it be open source or something else, giving that visibility and really being able to share that visibility so they can tell me and so that I can tell someone else. We don't have that whole chain. It's not that software supply chain, the chain is not there yet. That truly be able to make that traceability and follow it through. We see it in some defense industries where they do and can trace all the way back. But when you're looking at commercial software and products, we don't have those all of those tools in place because it's not been a requirement to the in the past, right? You can't tell. I find it hilarious when they're like, well, give us the provenance of the software. Well, if there's X number of open source, I don't have that because it could have been written by, Tiger team or somebody, and you don't know who's behind all of that. So you don't have that data, or it could have been falsified. So we have a long way to go to be able to really look at this this whole supply chain, and that's where SBOM and just overall the industry needs to get better at, and being able to say this, this is how this activity it came about. And it's even proliferating more with AI. You don't know the exact training data. You've got unstructured data. How do you take that one byte and then put some information on that one byte so you know where it was and trace it? It's going to be, an astronomical task.
Yes. No, I agree with your comments. I think we have some ways to go, but I guess the future only looks brighter for SBOM as we look forward. I think with Alan Friedman and CISA have done a lot of evangelization and promotion, and I know in your industries, critical infrastructure and in medical and some others, things are fairly advanced, and in some other industries not so far along. But I think at some point, people will freely exchange SBOMs, maybe without as much question. But another topic that gets covered in your book a bit is IoT devices, and that one's a bit near and dear to my heart, a bit through the industry associations I'm in. But in 2016 we had the Mirai botnet attack, and that was pretty massive in scale. And I know as a company you probably have a lot of IoT endpoints, around at your physical locations, potentially open to multi-prong attacks and high volume attacks. What is your recommendation to handle, challenges with IoT devices in general?
Well, so you've got a couple layers, right? You've got IoT, you've got OT, industrial IoT. You have appliances that are meant to be defensive in nature, on the perimeter and in other fashions. And so I really recommend, for CISOs, for anybody else, and this is not it, everything everybody should know is you really need to know your asset inventory. But what we're not doing usually as part of that is effective threat modeling and looking at the defense perimeter. Now, a lot of places are. especially when you're looking at critical infrastructure where there's layered defenses using the Purdue model, different kinds of areas to do that. But your general enterprise, so let's just say you've got the manufacturing plant for potato chips manufacturer right there down the street from you. What are they doing in? Do they have a flat network? Are they, and they've got a corporate location on the second floor of that plant, right? And so they are doing financials, and it could be all on this one segment. And from an IoT device, I mean, there's cases where things have been, what was it, for you've seen fish tanks affected. You've seen other, there's all of these, let's just say, harmless IoT devices that have been ways to do lateral movement into networks. And so that's one of the reasons why I felt it really important to include the firmware and hardware in the book, is because we are seeing more digital products every single day. Right. If you are buying a, let's just say a smart oven, and let's say it's from a major manufacturer, but what about your knockoff TV, right? How is it? We've seen there's TVs right now, which are IoT devices being used for mining attempts, for DDoS. They've been jump points for different kinds of things. So the IoT industry, and just in general, if it's coming from a larger manufacturer that has product security and has controls and requirements in place, but in general, you can't assume that those IoT devices that you're buying at a big box store have those protections. Right. And that's one of the reasons why the FCC in the US is looking to do this trademark that they've just released the information on. And that's why in Singapore that they've started with their cyber labeling program several years ago. But it's going to take a long time. So there's going to be the cyber risk for those. There's going to be a differentiator. And I think that that's coming about where, people who are doing and bringing products into their business or home have to be able to judge. And that's why I included a lot of that in the book, is you need to ask your manufacturers. You need to consider that if you're buying, phones for every single one of your, person in your company, are you aware? Do you have the SBOMs for the 50 applications that come pre-installed? Do you know where they're manufacturing it? Why are we treating phones at the same level of concern that we may treat, the laptop you work off? So, yeah, so there's a long way to go in that sense.
Yes, and you mentioned a lot of positive initiatives, like I think Cyber Trustmark or other things are making some positive steps forward. But I assume that sadly, a lot of devices that one buys, maybe from not major manufacturers, but they might still have a default password to break into them. So I think there are a lot of guidelines in the UK, US, and other places to move away from that as a minimum requirement. But I think a consumer or an enterprise probably could buy in bulk devices with a password.
Right. Yeah, that resetting password on first use, because I mean, obviously, even in my home, router, if I forgot the password, I need to be able to reset it locally. But it should be forced to change at the moment. I mean, because it's before it's available from an internet connected facility.
Okay. Well, I just have two more questions. One was on chapter 6, was on cloud and DevSecOps, and that's an important space as everything seems to be moving toward the cloud. Is there an ideal integration of software supply chain security, the focus of the book, and the DevSecOps process related to the cloud infrastructure? How do you make that work?
What I'm seeing is that overall, and I want to praise the companies, the Azure, AWS, and all of them. They're doing what they can to help provide security controls and secure platforms so that those moving through the infrastructure are doing what they can to secure the environment. So every day that they're working through those. But there's two concerns that I see frequently, is that people get complacent and say, oh, well, the infrastructure service or wherever we're going is going to do all those controls. That's not the case. you really need to understand the architecture of what you're building and how you're going to maintain it, because if they release new security controls or change something, that can change in your environment, right? So if you're not aware, that those changes are happening. And so, when we talk DevSecOps, for example, there is, and even just DevOps, there's a understanding that those teams have, and I would say it's only usually a partial understanding of the entire environment and the risk that may be. They're not really assessing, an expanded view of the risk. If they are more on the development side, and then they're doing the operations because they need to, they don't really understand all the operational risk. If they're mainly operations people and they're working a bit on the dev side to help with the pipeline, they don't understand the full dev because they don't know the full tech stack within. So there's tools out there that are better at. I think no matter what, you've got to have continuous scanning, pen testing kind of models to be able to look for those risks. And this again is where I think AI is going to help. In fact, a company just released and announced, a large one just released and announced a new security center product and things like that, that are going to be looking for those holes within the infrastructure itself. From a DevSecOps, one thing that also gets unfortunately missed is people change, and really don't even have a good, it's shared model. So let's talk about the shared responsibility model. And that's maybe discussed when they're starting a project, like who's going to be doing this or that. Well, but things change over time, and do you have that in set for contractual? And that's where things leave, because you've got business people and tech people, you've got multiple parties that are involved, and they're not really maintaining and aware and evaluating that threat model. Threat modeling should not be a once and done exercise. It should be, especially in the case of DevSecOps, that threat model should also be looking at what are the potential, internal controls that we need to do to keep it. Not just, we're protecting the SaaS environment, but what are the internal controls that somebody can laterally move into that movement, into that infrastructure and pull things down, because it is somehow usually connected into a corporate network at some point, or how the infrastructure is. And so DevSecOps definitely has a long way to grow, and a lot of people will show the infinity sign because it's just continually, you've got to keep working through that whole process.
Right. So no, you made some good points. The people that provide the cloud infrastructure are providing some security tools, but there are a lot of things you can layer on top of that to ensure you're safe. So, and the last question I had was kind of going back to what you said motivated you in the beginning was suppliers. You have a whole working with suppliers, which you do a lot. So there's a whole chapter 9. And I know you need to, when you're dealing with suppliers, assess their risk and how do you manage that risk in working with them. And in some cases, since you're a larger enterprise, and as is the case with other large enterprises, you may be able to ask smaller vendors to do whatever you need. How do you work that in the case of large vendors like, Google's or Microsoft's of the world, which obviously you must work with them as well. How do you manage potential risks in working with larger partners?
Well, I do include some suggestions in the book. It is not just because as a large customer doesn't mean that we have all of our questions answered too. I still don't have the SBOMs for the .NET DLLs. I would love them, right? So eventually, hopefully, I'll get those. So I recommend research. There's a lot of open source intelligence. There are services that can monitor that. Before anything, when you're looking at a supplier, or if you've got existing suppliers, a CISO, and that's the whole reason why I wrote this section, is that you probably, as a cyber leader in your organization, do not have the person power to be able to deeply assess even smaller or medium-sized suppliers. So having the research and what are the things you're going to pinpoint on based off the intended use. So if you are, as I mentioned earlier, like printers, like the intended use of a printer, is fine. It's really more about the controls that you put in as you put it on your network. So I'm not going to ask Apple or HP or anything for a detailed list of assessment questions that they have to answer for that product. Now, however, let's say I am buying a product and I'm at a manufacturing site and want to buy it from a specific supplier, and it could have safety concerns, or it could have this or that. That intended use is much more different. And in that case, it is much more difficult for smaller suppliers to do it. So I recommend, working with ISACs or other people in your peer groups to find this information out if they have it available. Overall, I find that if you go through the standard routes, sometimes that doesn't work. But small companies and small customers that reach out to our CISOs and our cyber teams all the time, and we do what we can. We provide answers to their questionnaires. So I think that you can't give up hope if it is a large manufacturer. Sometimes you've got to find the right person to have off the record, confidential conversations, but you don't want to spin your wheels if it's not there. So really being able to look at that research and planning to assume, I hate to be a bit negative on this, but we see everybody being attacked these days, right? So you have to assume that maybe Teams is going to go down for a week at some point. What are you going to do as a leader in your company? What are you going to do if this tool's not available? Do you have that? I know it's not really cool anymore, but for a long time there was a lot of disaster recovery and business continuity and things like that, and we need to get back into that habit. And that's why looking at your supplier and the resilience and understanding your plan, like what happens if they're not available for a week, a month, a day, a minute, what are you going to do, and what's that in? And that helps prioritize how much time you want to spend with that supplier and how you're going to sort of jump through hurdles to try to get a hold of that supplier.
Okay, no, good point. So we still need to stick to some of the basics of contingency planning and backup planning. I was reminded of this a few weeks ago when I'm based in Austin, when our mobile phone network went down, and actually across a big part of the US, I had family relatives in different parts of the country that lost cell coverage, and you kind of took for granted being able to map it or get the weather or do anything. Take for granted. So in a business sense, it's probably even more important to have those backup plans in place. So
yes.
Well, thank you for your time with us, and thank you on behalf of MergeBase, and I really appreciate your time. I know you're busy promoting the book as well as doing your day job, and I highly recommend to everyone to get a copy of Software Supply Chain Security, whether you're in supply chain security or just in cybersecurity in general.